So we have detected object previously. But what if I tell you last time we had to train our model? But this time, what you have to do is nothing. You just have to take a model, give it some images, and it will draw a box for you. I mean, it will detect objects for you. How cool does it sound? Welcome to the first part of transfer learning. Today, we are going to learn how to do one task using another agent that is already being trained. Okay, so firstly, what we will do, we will take resonant 50 and we will apply it to some object detection part. Okay, sounds good. So without further ado, let's get into it. Okay, so welcome to the tutorial part of this video. Firstly, what are we going to do is import some libraries, as always. As you can see, we are in the collab repository, that is research space currently, and for using this models and all, we are going to use Hugging Face. Okay, so firstly what we will do, we will make our app file here. We will deploy it to Hugging Face space. Okay, we will create a space there and deploy our files, and then lastly we will do our thing of like detecting objects. Sounds cool, right? So yeah, without further ado, let's get started. So firstly what we will do, we will import some libraries. So for this we will need Gradio. What Gradio does, it provides us with some interface. It's like Streamlit, but yeah, kinda like has some advantages, disadvantages, doesn't matter. Well, it will work cool with our app though. Then we will need PIL. From that we will need image, then image draw, as well as some image font to like draw some names on the image. Okay. Then obviously we will need transformers, and from that we will need a pipeline. Which pipeline? Obviously ResNet50, which is from Facebook. Okay. Specifically we will do DDR ResNet50. Okay. Okay, so let's get into it. So firstly what we will do is import some libraries. So I'll do a comment as import some libraries. Okay, so I'll do import Gradio as GR. Okay, and then we will import from PIL image. I think it has. I think we don't need image though. We'll import image draw and we'll import image font. Okay, then we will import pipeline from transformers. From transformers we will import pipeline. Okay, we will run this and it will run fine. Okay, till then what we will do is make an object detector pipeline. So we will define our model, define the what happened. Okay, no Gradio available, so we will do pip install video. That should not work because there is one L. So that should work. Okay, we will define the model pipeline till then. Okay, so what we will do is, let's say object detector equals to, we will do pipeline, and we will import the pipeline for object detection, and then we will define a model as Facebook/DTR resonant 50. Okay, we'll run this and it should run fine. Done. The config.json has been imported, so yeah, it will run fine. Okay, so till then, till then what we will do is we will make a function to draw bounding boxes, as well as we will make some things to like actually detect the object, right? So firstly we have to detect the object, and then we will need to draw the boundaries. So yeah, but still we will make a function first to draw a boundary, and then we will make a function to detect some objects. Okay, so to work with this function, what we will do, we'll mostly use Gradu. Not Gradu. Okay, we'll do def. Let's give it a headline, a comment as define a drawing function. Okay, so let's say draw boxes. That seems fine. It will take an image, and it will take the detections that other function has done. And we will do font path as none. Then we will do font size as 30. Okay. After this, what we will do is draw the image. Okay. To draw the image, what we will do, we will have an original image, right? We will not draw it itself. We will make a copy of it, display it to another the image container or a compartment, as you may say, and we will draw the squares on it. So there will be two halves of images. First will be the uploaded that we will be uploading, and the other one should be the one with the boxes. Okay, fine, sounds good. So what we will do is define an image. Let's call it draw image, which will be a copy of our image. So image.copy. Okay, then we will do actual draw with image draw function, which will draw the things on draw image. Okay, so this draw will draw something on this image, okay, which is the copy of our original image. Sounds a bit weird, but yeah, that's it. Okay, so now there's one thing. If the font path is there, that is being provided, okay, we will do font equals image font dot true type, and we will do font path and font size. Exactly what we need to draw letters on the image. Okay, if it is not present, we will do else font equals image font dot load default. So if we have provided something, it will draw in that font with a specific size that we have defined, and unless we don't provide something, it will be a default. Okay, so that's it. So now for what we will do, for each detection point we will draw on the image using the ymin, ymax, xmin, xmax. Yeah, right. So we will work with the coordinates, right? So let's do for each detection in the detections, which will probably a list. Okay, we'll do box equals detection and we'll do box. Okay, we have defined the box. We'll define the x mean as box of x mean, then we'll do y mean, then we'll do y max, and then we'll do x max, right? Y mean, this should also be y mean, this should be x max, and lastly y max. Okay, sounds cool. So our box is done. Now we will actually draw the box. Okay, so what we will do is draw dot rectangle, and we will pass it the array of tuples which will contain the minimum and maximum values. So the x mean and y mean should be together, and another tuple with x max, and guess what, mx. Okay, after that what we will do is we'll do outline equals, let's give a red outline because why not, it is the most eye-catching color that everyone knows, and let's give it a width of, let's say 5. Okay, so the 5 pixel width, not the pixel, I don't know what measure it is, but let's see how 5 works. Okay, so let's optionally let's draw a label if provided. Okay, so it depends on if it has been recognized the image or not. Okay, in the ResNet 50. Okay, so let's do label equals detection of label. I'm sorry, I'm not working correctly. Label, and if I go down, it should do score, that how much percent it sees this as. I hope you get me. And again, in the last column, we will do the actual text, which actually does not need this, but an f string which has the, let's say, label, and then the score at 2 decimal places, so 0.2f. Works fine actually, I hope. Okay, so what we did till now, we took an image copy, we defined a draw function to draw on that image. If a font path is defined, then that font will be used. Until and unless we don't do that, load default, the default will be loaded. Okay, so with the detections of our ResNet 50, what we did is we defined the boundaries, like the 4 points of a rectangle, and we actually drew them with an outline of red and a width of 5. Okay, then lastly, a label is provided by ResNet 50, that is, if that object is being recognized by ResNet 50 earlier when it was trained, trust me on this one, it will not be trained on your data, you'll just be providing the image and it will be giving you the detection. Okay, I hope everything is good. Okay, so it is optional. If the label is present, it will be there. If not, it will not be there. Okay. Okay, done. So let's draw a transparent rectangle. Okay. So if font path is present, the text size equal to draw dot text box. I guess it was x mean and y mean. Yep. So it will be on the the top left. Then the text would be there and the font would be there as font that is being provided. Else, if it is not present, the text size would be my typing is not good today. Draw text b box, and then we will just draw again on the x mean and y mean with just the text and not the font. Okay. If font is present, the font will be there. If not, no worries. Okay. Lastly, we will again provide an actual thing to draw a rectangle. So what we will do is draw a rectangle. So let's do draw underscore rectangle. It is not underscore, it is dot here. And we will provide it the text size of 0. Then we will do text size of 1. And no, I messed up. This should be in the tuple again. Yeah, now it is good. And after this tuple, it should be text size of 2 and then text size of 3. And yeah, that should be good to go. But no, it is not, because why? I don't know what happened. Okay, messed up here. Also need a tuple there. Okay. After that, we need to fill with red. Okay. So after filling it with red, we will do draw dot text, and we'll do a tuple at mean and y mean. Again, we will do text, and we will do field equals white with we will do white with inverted commas, and then we will do font equals font. Okay, I'm sorry, I'm not feeling well, so my voice must be not coming properly. Sorry. And lastly, we will return the image that is being drawn. So if we run this, it should run fine because nothing to worry here. Lastly, we will detect the object. Okay. So now we have drawn the boxes. Now what we will do? We will detect the object. So let's define a function to detect the object. Detect the object in the image. Okay. Def detect object. Let's call it, and it will have an image obviously. And now we will do raw image and as image. Okay. Now we will get an output from the function that is defined above. Okay, so now what was the name of that function? Perfect draw boxes. So let's say draw. Sorry, we will firstly take the output of an object detector with the raw image. And I hope object detector is fine. Yeah, it is good. And we will process the image. Let's do processed image equals to, and now we will call the function. So let's do draw underscore boxes. Now in this function we will provide the raw image and we will provide the output. So it should be drawn, and now lastly we will return the processed image. Okay, this should run fine. Yep. So now what we did was we created a copy as a raw image. We provided it to the ResNet 50 and got the array output. If I I can't print it right. Yeah. If I print it, it will contain various regression values which will define the coordinates of the boxes, right? Okay. So from that we will take the x mean, y mean, x max, y max to draw a rectangle, and we will draw a rectangle with red outlines and 5 width. Okay. Lastly, we will do demo. For this demo, we'll create a demo interface with Gradio, which is very easy to do. Okay. So what we'll do, let's call this as demo only, and let's do gr.interface, and we'll provide it the function fn to detect object. Okay, then we'll do inputs equals to, we'll provide an array gr.image, which will have a label as select image. I hope I'm doing this correctly, and I guess it is type. I'll provide the type as PIL, because why not, it is a PIL image after all. Okay, again we'll do outputs equals to again gr.image. For that we'll be labeling it as what processed. This should be in the method. Processed image. Okay, and this should also be the type of it. Okay, now we'll do title, which has small title. Okay, title equals to detecting objects with transfer learning at Pianalytix. Okay, and lastly we'll do description equals to this app will allow you to run ResNet 50 trained by Facebook to detect objects. Okay, after that what we'll do, demo.launch. I'll not run this because we are in collab. Let's run this. Let's see what happens. We go to this URL. So once you go to that URL, what you can see is you are actually prompted to like upload an image. And what I'll do now is let me just clear my things. Okay, let's do cat image. So I don't like cats though, so we'll do dog images. Okay, and let's get these ones. Okay, if we do save image as well as do desktop, save it, cut this, then do this and open it. It should be uploading fine. Yeah, and if we submit, it is processing. As you can see, it has detected some objects. So it actually like detected bench with 99% of accuracy. It detected this dog with 87% of accuracy and this dog with 98% of accuracy. Quite cool. And what I was telling you about, what do you say? Let's do the webcam thing. Okay. It will ask me the webcam and until I close this site and allow it. I don't know what happened. No worries. I guess my webcam didn't fire up. Who knows? Still, it's okay. We'll upload an image. Let's upload the same image again. Let's see what happens. So reload to पहले. Upload the same image. See, this time the accuracy of this dog went from 86 to 87, I guess. I don't know. I don't remember the numbers. I am having some issues currently with remembering things. Okay, it's okay. I hope you have enjoyed. I hope you have understood how can you make like a well-deserved object detector using like transformer pipelines. So yeah, that's it for today's video and I'll see you guys in the next one. This is Atul from Pianalytix and bye bye.